So in this video, we're going to discuss two topics: scalars, the difference between a scalar quantity and a vector quantity, and then we're going to talk about how you can um, add uh, add vectors together, subtract vectors, and how you can multiply a vector by a scalar number. Okay, so these operations you're going to use a lot in these class, and it's very important that you understand the differences between scalar and vector quantities. So a scalar is a physical quantity defined by its magnitude. Some examples of scalars are time, temperature, length, and mass. Okay. Vector quantities are physical quantities that have both magnitude and direction. In two dimensions, the direction will typically define using an angle, such as the angle theta. So in this class, we're going to be focusing on the primary vector. We're going to be focusing on our force vectors. We will also talk in a few lectures about position vectors, and unit vectors are the main vectors we're going to discuss in this course. So for a vector, let's say if we have a vector like a force vector, we can call that force A. It will have force A will have two components. It will have a magnitude, so we can write the magnitude either using the double hash marks, or we can write it as just the letter A without the line over the top. And then, so that's our magnitude. And then for the other important quantity of our vector A is the angle theta. Alright, so this is the direction of vector A with respect to the x-axis, the positive x-axis. Okay. All right. So with that being said, there's certain operations that you must be able to do, or you'll do commonly in this course. One of them is if you're going to multiply a vector by a scalar number. So for example, if we have our original vector, vector A, all right, and vector A, all right, we can draw out, let me draw it. All right, and vector A has an angle theta. Okay, all right, if we multiply vector A by a scalar number, like let's say for example 2A, all right, its length would get multiplied by 2. Right? So the length of the vector is 2, the direction is the same. If we multiplied the vector A by half, you'd imagine that the length of the vector would change to be half of its original length. All right, but the angle is still the same angle. All right, and then the last thing is if you multiply by a negative number, a vector by a negative number, what ends up happening is it goes, the direction goes in 180 degrees, or rotates 180 degrees. So originally, our vector was an angle theta from the positive x-axis. It will be at an angle theta from the negative x-axis, but it'll still have the same magnitude. It'll just be going in the opposite direction. Okay. All right. So then, the next operation would be for if you need to add two vectors together. Alright, so we can do this vector addition graphically using these two laws. So we can use either the parallelogram law or the triangle law. So if we do, we're going to talk about the parallelogram law first. So what the parallelogram law states is that our resultant vector is going to be equal to the addition of A plus vector A plus vector B. Okay, so what we would do is our first step is we're going to draw vector A and vector B from the same starting point. So we'll draw vector A going this way, and we have vector B being drawn this way. Okay, so these are given quantities. Okay, so the second thing you will then do is you're going to draw a line from the tip of vector A that is parallel with vector B. Okay, and then you will draw another line from the tip of vector B that will be parallel with vector A. Alright, and what this does is it creates a parallelogram, and then where our two lines that we drew met, alright, that intersection will be where our resultant vector, or the addition of these two vectors, would intersect. So to determine the magnitude of our resultant vector, is all we would do is we would draw a line from where the two vectors A and B start, and to where the two lines that we drew that were parallel with the two vectors connect. Okay, and this would be our resultant vector. Okay. The second way we can add two vectors together graphically is we can use what's called the triangle law. So we need to have so again, this is sometimes called the tip to tail method. So what we're going to do is we're going to find the sum of A plus B to find our resultant force, what we can do is we can take we can draw vector A, right, and then at the tip of vector A, we're going to draw the tail end of vector B. Alright, and then our resultant vector will go from the tail end of vector A to the tip of vector B. Alright, so what I'd like to mention here is that it doesn't matter which vector you start with. You could have done first drawn vector B first, and then you could have drawn vector A from the tip of vector B. You could draw the tail of vector A to the tip of vector A, and then you would have still gotten the same resultant vector here. Alright, so in short, it doesn't matter the order in which you add two vectors together. So vector A plus vector B is the same thing as vector B plus vector A. Okay. Alright, so the last operation we're going to talk about for vectors is vector subtraction. So if you want to find the difference between vector A and vector B, alright, that's the same thing as saying would be the same thing as adding vector A times the vector B times -1. Okay, so if we have two vectors, vectors A and B, drawn at the same point like we did before, to do this operation here, we'll use the tip to tail method. So we'll start off with vector A, okay, and then we'll add negative vector B to vector A. So we'll use the triangle law, and we'll be able to draw our resultant vector here. Okay, so I'm going to call this resultant vector vector C. Okay. Now, the one thing I will point out is the order that which you do this does uh, 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 the order in which you do this does matter, and the negative sign on which vector does matter. So just to show you, so we're going to now look at if you subtracted vector A from vector B, what that would look like. So we would first draw vector B, right, and then we would draw vector A, negative vector A, all right, and then we would draw our resultant vector. We would draw from the tail of vector B to the tip of vector A. Alright, and that would be our resultant vector, which I'm going to call vector D here. Okay. So what you will notice is that vector C is going to be equal to the negative of vector D. Okay, so they're 180 degrees apart from each other. Okay. Alright, so that concludes this video on the differences between scalars and vectors, how you can multiply a vector by a scalar number, how that might affect its magnitude and its direction, and then how you can add vectors using the parallelogram law, the triangle law, and then how you can subtract vectors using the triangle law as well.